Okay, so we're starting chapter 8. I know we have not tested on chapter 7 yet. That's going to be on Thursday. I pushed back the test, but we still have to keep going in order to get through this chapter. This will be the last chapter that we do for the quarter, for the year. And it's all on quadratics. And if Mrs. Cermak taught you anything, you should know that a quadratic is a U-shaped graph, right? Okay, so we're going to go through a lot of vocabulary before we get to the actual practice part. So our first definition here is a function that can be written in the form of ax squared plus bx plus c. That is called a quadratic function. Okay. The simplest quadratic form is f of x, or y equals x squared, and that is called our parent function. If you remember back to linear transformations, we had a parent function of y equals x squared, or y equals x. The difference here is that this one is y equals x squared. All right. The standard form of a quadratic function is written as ax squared plus bx equals c. Okay, so this would be the correct way to write it. Now, when I talk about your A, your B, and your C, you should know that I'm talking about the coefficient in front of your x squared versus the coefficient in front of your x, and then your constant c. Okay. The graph of a function, or the graph of a quadratic function, is called a parabola. Okay. Now we're going to go into some vocabulary dealing with a parabola. The first one is axis of symmetry. This is a line that cuts your parabola in half. If you think of something being symmetrical, if you were to cut it in half, it would mirror. And your axis of symmetry would look like this. Okay. With the line going straight down the middle. Okay. Now, if I were to look over here at this parabola, the line that goes straight down the middle of our parabola would be this right here. And you're going to have to identify your axis of symmetry. So if you wanted to write that would be your axis of symmetry.
Could you go on the way?
Okay, the next one is your vertex. So your vertex is the highest or lowest point of your parabola. So in this case, our lowest point would be where the axis of symmetry runs through and touches the lowest point on the parabola, or the highest point on the parabola. The difference is if it is the lowest point, let's see, we're going to do the maximum. Okay, so this one is the maximum. This is the vertex that opens downward, and it's the maximum point of your y-coordinate. Okay, that sounds a little bit confusing. But your parabola will open downward, and the maximum is the highest point or the highest y value that you will see. Okay, so if you look at this as on a coordinate grid, let me draw that really quick. If you were on a coordinate grid right here, and you had a parabola going through that coordinate grid, this maximum is the highest y that you will see. And if you remember domain and range, y is your range. Okay, we're going to get into that a little bit more. And then your minimum would be the is when the vertex of the parabola opens up, and it would be your lowest point on the parabola. Okay. So going up to, and this will all make sense when once we start practicing it. But if you go up to this parabola example right here, the parabola opens upward. Okay. So if it's opening upward, that means we have a minimum, and your minimum is going to be wherever your vertex is. So this right here is your vertex. Okay. And the vertex is -2, -3. Okay. And it is your lowest y value. But if you notice, if you look at your y, it starts at -3, but then it goes up infinitely, right? You will not have anything below 3 in this parabola. Okay. All right. So the next vocabulary word is where the graph crosses the x-axis, also known as solutions to the quadratic. So you will see this written two ways as your x-intercept, also known as zeros. So anywhere where the parabola crosses the x-axis, those are it, or the x, yeah, the x-axis, that's your x-intercept. So if you look up here, you have it crossing the x-axis in between -4 and 5 and in between 0 and 1. Those are your x-intercepts. Sometimes it'll cross at only one point. Sometimes it'll cross at 2, and sometimes it won't cross the x-axis at all. The next one would be your y-intercept. There are no additional names for this one, but it's where it crosses the y-axis. We know about this. And where it crosses the y-axis is right here at -1. So this is your y-intercept. Okay. Okay. The interval of x values in a function, this is called your domain. Sometimes we represent it by an R that looks like kind of like this. You may have seen it also, or we have written it like this, right? Where there's an infinite number of solutions. So the types of parabolas that we are going to be working on, your domain will always have an infinite number of solutions, because it will touch every x value on your coordinate grid. And then the interval of y values is called your range. This we will write as in this function notation, but it'll look a little bit different. So let's go up here. Up here, our domain is all possible x values. So the numbers that it will touch along the x-axis. And I want you to think about this parabola. It's going to continue to go up and up forever. That's what the arrow says. And it will eventually touch every single x value. So this one is, oh wait, this should be a negative. Negative infinity is less than or equal to x, which is less than or equal to infinity. Okay. Even if it were to go downward, I know this is a lot of information, Even if it were to go downward, it would still be infinite number of solutions. And then your range is all possible y values. So because it is a minimum, we have a -3. Your minimum will go here, -3. And our y value is going to be greater than or equal to -3, but less than or equal to infinity. Okay. I know it's a lot. I know you guys are looking at a lot of information. But once we get to the practice on the next page, some of it will make a little bit more sense. All right. Let's go ahead and go and look at some graphs. Okay, so we are going to label or identify the key characteristics of this graph based on the vocabulary we just went over. So the vertex, if you needed to look at the other side, the vertex tells you that it is the center of your parabola. So if we were to come over here and find the center of our parabola, I want you to do that. I want you to go ahead and find the center, okay, and put a point next to it. Okay, it's right here. What is the ordered pair for that vertex? 1, -4. That is your vertex. That's not difficult, right? The vertex is your most center point. And then your axis of symmetry is just the line that cuts that parabola in half. Okay, and so here we're going to cut that line in half. Create a dashed line on it. It's a little hard to see. Doesn't have to be perfect. Okay. And when you write what your axis of symmetry is, it's going to go through the x-axis. So you're writing it as x is going through 1. So your axis of symmetry is written as x equals 1. Okay, now we have to look at this as, is it a maximum or a minimum? Look at your y value. Is it showing that your y is at the bottom of your parabola or the top of your parabola? If it's at the bottom, it's a minimum. If it's at the top, it's a maximum. So what would this be? Yeah, it's a minimum. Okay. And your minimum is at -4. So y equals -4. Your minimum will represent your lowest or highest y value. Okay, these are easy, right? Where does it cross the x-intercept? Where does it cross the y-intercept? Okay. So our x-intercepts, we're supposed to mark the point, is here and here. And we're just going to write those ordered pairs out. So we have -1 and 0. And 3 and 0. Okay, what about our y-intercept? Yeah, 0, -3. Okay, now we're going to write out our domain and range. So what x values will this domain hit if it keeps going out in space to infinity? Infinite. So it's going to go infinite in the negative direction. And it's going to go infinite in the positive direction. So we would write this as function notation where it looks like this. Okay, and then our last one is our range. So if we look at our y value cannot be less than -5. So when we write this out, I always ask myself, can it be greater then what is that? Negative, what did I just say? -4? I said 5, I think I meant 4. So can it be greater than 4? Yes, it can be. So it's going to be greater than or equal to -4 and less than or equal to infinity. And all right. Yes.
So for the domain, don't we just write that same thing every time?
For this, yes. When you get into algebra 2, we get into some different types of functions where you wouldn't write it like this, but for what we're doing in this class, yes. Okay. All right, any questions? Okay. Let me see if we have another one of these. Okay, you guys think you could try to locate these things on your own? Try with your partner, see if you could figure it out. And then we'll come back and check it. Okay, so go ahead and check example 2, make sure you got everything correct on that. Oh, by the way, I did make a mistake up here. Your domain should have negative infinity to infinity. So if you didn't put that negative, put the negative there. Okay, so we're going to go now to page 3, where we are going to graph a parabola. So let's go ahead and flip. Now, I don't think I could say this enough. When you're graphing a parabola, you get to choose your points. But you want to try to choose points that make sense. Okay. So sometimes what we do is we plug in like 0 and -1 and 1 to see where those points lie. And so that's what I'm going to do here. I am going to plug in a -2, a -1, a 0, a 1, and a 2. Okay. Now, we did this at the very beginning of the year with linear functions. We created a table of values. We plugged it into the equation. We solved the equation for y, and then we graphed our line. This is no different. Okay. This is just a parabola instead of a line. So let's go ahead and do our work over here. If I take y equals -3 times 2 squared, because I'm replacing my x with the -2, oops, a -2 squared. I get -3 times 4, which equals a -12. So my f of x is -12. That's what you're going to do with each one of those. Okay. Y equals -3 times -1 squared, which equals -3 times 1, which is -3. So do that for all of these. And you should see a pattern. Okay. Now what I want you to do is I want you to graph this parabola. And of course, your -12 is going to go off the grid just a little bit. So just kind of estimate that. Now it almost looks like a V, but this is a parabola. It should be a U-shaped. And you just graphed a parabola. Now, based on this, you should be able to identify all of the key characteristics right here on the bottom. Okay, so let's go ahead and look at this. Our vertex. What is our vertex? Yep, it's at the origin right here. This is our vertex. It is 0, 0. Our axis of symmetry. It's 0, x equals 0. Because it goes right through the y-axis at 0. Now, is this a minimum or a maximum? It's a maximum, and the maximum is y equals 0. So think of this axis of symmetry has an x in it. It represents the x. Oh, maps has an x in it too. Never mind. I thought I was going to make a connection there. I did. All right, our x-intercept is 0, 0. What's our y-intercept? 0, 0. What's our domain?
Negative infinity.
Yep. And our range, this would be the what? Yeah, y isn't greater than 0, right? Y is less than 0. So then this would be, that's how I always think about it when I'm trying to figure out range. Okay. Now, notice or are there any questions before I move on? Okay, let's look at example 4. I'm going to start with -2, -1, 0, 1, and 2, just like I did before. And I might have to add some additional numbers in there. Now, I've done this, so I already know I'm going to have to add a lot of numbers. Your goal, though, is to find the vertex and go from there. So I'm going to show you this way, and then I'm going to show you the vertex, finding the vertex way, and it'll make it a little bit simpler. But let's just go with what we know here. Okay. And let's see if this makes sense, if this is going to form somewhat of a parabola. Okay. So you're going to have to solve all of this. Okay. So we have -2 squared minus 4 times -2 minus 5. Okay. Some of you can do this in your head. Me, I write it out because I don't want to make a mistake. Okay, when you plug 0 in, there's not a whole lot of work that needs to be done because you know that this is 0, this is 0, you're left with a -5. Okay. And I don't see a pattern happening. You should see a pattern happening.
Well.
Yeah. But the closer the numbers get, the closer you are to a pattern. All right, so I'm going to add 3, 4, 5, and 6. This is a lot of work, I know. But look at this, we're back to -8. So we had found a pattern. I think I did something wrong.
3 instead of 4.
4, thank you. There we go. And then you can probably pretty much figure out that those are gonna all line up like that. Okay, so now let's go ahead and graph our parabola. I messed up. Why are you laughing? Because I plotted it wrong?
No,
Because your hair was the one here.
Oh, it was. Like, what? You guys don't usually laugh when I make mistake. You let me know. Is it still in the camera?
No.
I can't see. My eyes are
Stronger reading glasses.
probably 3, -8, 4, -5, 0, 6, 7. Okay. Now, I'm just gonna tell you that you really don't need this many points. How many points does a linear function require?
2.
2. A quadratic requires. Okay. You really only needed these 3 down here.
Wow.
So my question is. How can we find an easier way to locate that vertex so that we don't have to go through all this work? And I'm going to show you right now. There is a formula. And I'm going to write this up here. It is x equals -b over 2a. -b over 2a. So what we're going to do is we're going to take this equation right here, our coefficient here, 1, -4 and 5. This is a, this is b, this is c. Okay. So, and the negative in front of the b represents a -1. So if our b right here is a -4, we're going to take -1 times -4 over 2 times a, which is 1. And we'll solve that, and it will give us the x of our vertex. Okay. Is this confusing? Yes, it is. So guys, listen, some of you have not had to study. This might be a time where you're going to have to start studying your vocabulary and how to do these things, because it's not going to come easy. Okay. So -1 times -4 is 5 over 2. Is that right?
4 over 2.
Oh my goodness. I was like, wait, this isn't turning out right. Thank you. 4 over 2. So our vertex is 2. Does that make sense that our x would be 2? Or x is 2? It is. In our vertex, what is our vertex down here on our graph? 2, -9. So then what you would do is you would place 2 into the equation right here, and you would get -9, and that's your vertex. Then you know all that you have to do is you have to go up 1 and down 1 for your x.
Wait, you placed 2 where in the equation?
And okay, so your x is 2, right? So you place 2 where the x is in your equation, and you solve for y. And then all that you would have had to do was do these right here. Wait. No, right here. 1, 2, and 3. You wouldn't have had to do all of these other ones to try to figure it out. All right, we're gonna practice this some more on the other side. So I want you guys to go ahead and locate all of these key characteristics, and then we will. Okay, go ahead and check to make sure this is correct. Great. Any questions? Yes. Okay, so the range is all of your possible Y values in the graph. Okay, so in this case, my Y axis right here, I'm gonna check along this axis. And I noticed that the lowest Y value is -9. I will not have a Y value below that. So I know that my Y has to be -9 or bigger. So when I find the range, my Y has to be greater than or equal to -9.
So if the graph is flipped over, like in this shape,
Uh-huh.
then the -9 will be on the other side.
Yes.
When is the homework due?
Not till next week. Okay, we're gonna practice finding. Okay. Let's go ahead and look at these. I'm gonna. Hold on, let me pause this real quick, just a second. Oops, hold on. I know, all right. Okay, we're gonna skip page 4 for right now, and we're gonna go to page 5. I want to practice the finding the vertex. Okay, so I'm gonna go kind of slow because I want to make sure you guys understand this. We want to graph -2x² + 7. Okay, but maybe we don't know where to start. We don't know where that pattern is going to fall. So if we find the vertex, we'll be able to figure out that pattern. So remember, the vertex formula to find the x value is -b/2a. Okay? Do you notice anything about our equation though? It doesn't have a b, which means our b is 0. So we have a 0 over 2 times, what's our a? -2. So we're gonna multiply that times -2. Okay. Any questions so far? Sam?
How are we missing a B?
Well, because the standard form is ax² + bx + c. We don't have a bx. We just have an a and a c right here. Okay. I'm glad you asked that though. So here we have 0 over -4, which equals 0. So I know that my vertex is going to start with a 0. I'm going to put that in the middle box right here. Then I'm going to solve for my y by plugging 0 into this equation and solve for y. Now we should be able to do that without any math. Yes, if you plug 0 into this x², you're going to get 0 + 7 or 7. So this is our vertex right here, 0, 7. We already know that. So we could plot that point on our graph if we wanted to. Now what I'm going to do is I'm going to go down 1, and I'm going to solve for a -1, and I'm going to go up 1 and solve for a +1. Okay. So let's do that. We're going to take this equation right here and we're going to plug in our 2x values. And you'll notice that both your y's are the same, so let's plot those 2 points. We have -1 and 5. And we have 1 and 5. So much easier than trying to figure out what those points could possibly be. And you'll see that a little more as we go and practice some of these problems. Sam,
The lines don't have to be straight, right? That you don't need a rubber.
No. there's no way. Yeah. All right, so let's figure out the domain and range. What is the domain? Yeah. Now, what about the range? Is that our bell to go?
Yeah.
Oh, great. Okay, so this is what we're gonna do, you guys. We will finish this lesson tomorrow. Okay, so let's go ahead and continue with example 7 here. Like I said, trying to find the vertex is a lot of times easier to help you graph the parabola. So I'm going to write out our vertex formula. X equals -b over 2a. Notice we don't have a b in this one again. So it's going to be 0 over, oops. 2 times 3/4, which is 0 over 3/2, which is just 0. Okay. So I know my x is 0. And when I plug the x into the equation for 0, my y-intercept will be -2. Okay. Now, again, I'm going to go down 1 to -1 and up 1 to +1, and I'm going to find the next 2 ordered pairs so I could plot my parabola. So actually, because this is a fraction, instead of choosing -1 and 1, I'm going to choose a factor of 4 so that I can easily get rid of that fraction. So instead of -1 and 1, I'm going to choose -4 and 4. And this is why. I have y equals -3/4 times -4 squared minus 2. Okay, so here we have 3/4. -4 times -4 is times 16 minus 2. Then 3/4 times 16, I'm going to cross simplify, is 12 minus 2, which gives us 10. So when x is -4, y is 10. And I could do the same thing for 4, but if you plug 4 into here, 4 times 4 is 16, and you're going to end up with the same answer here, 10. So now what I'm going to do is I'm going to go ahead and plot my points here. I have -4 and 10. I have 0, -2, and I have +4 and 10. And I can now graph my parabola. Okay, our domain is going to be all x values. And our range is a minimum. And so it is going to be, so the greatest that it will be is a -2. I'm sorry. The lowest it will be is a -2. So y is going to be greater than -2. and less than or equal to infinity. Okay, so now that we've done two together, I would like for you to do this next one on your own, and then we'll come back and check your work. Okay, go ahead and check your work on this one. And what I'm going to do now is I'm going to go back to page 4. And on these, we are going to graph each function and order them from narrowest to widest. And so what I'm going to do is I'm going to start with 0 in the middle. So all of my first sets, I'm going to take my table and I'm going to plug 0, 0 in there. Now, what I want you to do though, is I want you to choose points that make sense with your equation. So because this is a fraction, I'm going to choose multiples of 3. Okay, so I'm going to choose -3 and -6. And by doing so, that means that I'm going to get rid of the fraction and I'm going to be left with a whole number, and it'll be easier to graph. And then down here, I'm going to go with 3 and 6. And I am going to go ahead and solve this out. So I have 1/3 times -6 squared, which is 1/3 times 36. And that gives me 12. And again, my -6 and my 6 are going to be the same in this case. Now that won't always happen, especially if you have a quadratic equation that is written in standard form that has a B and a C. It will not always look like this. But I know just by looking at this equation that both my -6 and my 6 will be the same. And then this one, y equals 1/3 times -3 squared is the same as 1/3 times 9. And that is going to be 3. Okay. So let's graph this. So we have -6 and 12. And we're going to have to estimate just a little bit. About right here. -3 and 3. 0, 0. 3, 3. And 6. 12. Okay. And we're going to go ahead and draw that parabola out. Okay. And once we get all 3 of these graphed, we're going to figure out just by looking at the equation, what is going to, how we can identify a narrow graph versus a wide graph. Okay, I want you to go ahead and do this next one. We're going to use -2, -1, 0, 1, and 2. So go ahead and graph this one. And then we'll come back and check our graphs. Okay, go ahead and check your graph. You want to check your table, make sure your order pairs are correct. And then we are going to move on to graph 3. I'm going to go ahead and let you do graph 3 on your own, but I just want you to pay attention to the fraction here. You definitely want to choose multiples of 6, but I find that when you choose multiples of 6, and I'll show you what this is going to look like in a minute, that you're going to go way off your graph. So sometimes you may want to choose even smaller numbers, but let's just see what this looks like when we set this up. So we're going to start off with, I'm going to do multiples of 6. So -12, -6, 0, 6, and 12. And I want you to go ahead and fill out the table. I'm going to pause the video and then we'll come back and look at our numbers. Okay, so these are the numbers we have, and I want to go ahead and graph. I can't graph the 24 unless I go by 2s on my graph, but I want to go by 1s. So I'm going to go ahead and graph -6, 6, -6, 0, 0, and 6. And we'll go ahead and. So I'm looking at this and I'm not exactly sure how far down I need to go here. I want a more accurate graph. So what I'm going to do is I'm going to venture out into some decimals a little bit. And I'm going to choose two more numbers. I'm going to choose -3 and 3 here. And I'm just going to see what I get with these. Okay. So if I have y equals 1/6 times -3 squared, I get 1/6 times 9. And then I can simplify this. Nope. 2 and 3. And I get 3/2. And another way to write 3/2 would be a 1.5. Okay. So now I have -3 and 1.5 and 3 and 1.5. So I'm going to go over here and graph them, these two ordered pairs, just to get a better idea of the width of my graph. So I'm going to come over here to -3. Keep needing to put on my glasses. So -3 and 1.5. And then 3 and 1.5. And that gives me an idea of where my line needs to be drawn. So. Now you don't necessarily have to do this, but there was a point in me showing you these three graphs. And that is that I want to be able to, and I'm going to zoom out for just a second. I want to be able to look at my equations and identify whether my graph is going to be narrow or wide. And we do this a lot with transformations. So let's look at the graph. We can identify that this is the most narrow. Okay, this is the most wide. And this is in the middle over here, up here. So in looking at the coefficient of each equation, what do you notice about the most narrow and the most wide graph? These two coefficients. That's what I want you to think about. And then the conclusion that you should come to is that, I'm going to write it up here, the smaller the coefficient of A, the wider the parabola. Okay, and you should be able to identify that and put them in order without even having to graph them. Okay, so 1/6 is smaller than 1/3. Okay, so this graph right here would be wider than the top graph. This is the largest coefficient of A, so it is going to be the most narrow graph. All right, so we've completed everything but the last page of our notes, so let's go back there. Okay, so this function right here, h equals -16t squared plus c, a form of this type of equation you will see in many algebra 2 problems and with many quadratic functions involving real world situations. So you should expect to see this quite a bit. So what this function models is if you were to drop something from a certain height, it will help you to determine how long it takes for an object to fall to the ground. Okay, so let's just look at this. This function, h equals negative 16t squared plus c, models the height of a falling object. H represents the height. In this case, it's feet above the ground. T represents the number of seconds since the object began to fall. And C is the object's initial height. Okay, so C is the initial height. H is, it's where H is the object's height in feet, current height. Current height at like so many seconds. So what is the height at 3 seconds? What is the height at 4 seconds and so on? And then T is seconds. Okay. So let's look at our situation. We have an acorn and it drops from a tree branch 20 feet above the ground. The function gives the height of an acorn in feet after so many seconds. What is the graph of this quadratic function? About what time does the acorn hit the ground? So we're trying to figure out how long will it take for that acorn to hit the ground, and what will the parabola look like, or what will the graph look like? So what do we know? We know that the initial height which is C in our equation, is 20 feet. What are we trying to figure out? The time it takes for the acorn to hit the ground. Okay, and now we are going to make a plan. So we're going to set up the equation. With our given. And solve for H, okay? So here we go. Our equation is H equals negative 16t squared plus C. Well, our C is 20, right? So we want to take this given, the C, and we're going to add 20 to it. Now, when you're talking about a falling object, it usually takes just seconds for it to fall. Think about it falling from a tree. So we're going to use fractions in this. So we know that when our height or when our time is 0, that means the acorn is still at the top of the tree, right? If we were to plug 0 where the T is, we're going to get 20. We know that that's where it starts. It starts 20 feet above the ground at 0. Okay, the time that I'm going to use is a 1/4 of a second, a 1/2 of a second, and then we could do 3/4 of a second, and then we could do 1 second. I'm going to go beyond my graph a little bit. So we're going to have to do some math here. Okay, so I want you, okay, so what we're going to do, I'll do the math. So we have negative 16 times 1/4 squared plus 20. So we have negative 16 times 1/16 plus 20. And then these are going to cancel out. So we have negative 1 plus 20 equals 19. So this is 19. And now we have to figure out for 1/2 and 3/4. Okay, so let's figure out for 1/2. Negative 16 times 1/2 squared is negative 16 times 1/4 That's -4 plus 20, which is 16. So this one's 16. Okay, so let's do 3/4. -16 times 3/4 squared plus 20. -16 times 9/16 plus 20. These cancel out. So we have a -9 plus 20, which gives us 11. And then if you plug 1 in here, we have -16 times 1, which is 1, and then we would get a 4. Okay. Okay. It still has not hit the ground though, right? We still don't know what time it's hit the ground. I'm going to show you how to figure that out. But right now, let's go ahead and complete our graph. Now we're going way back to the beginning of the year where we did a whole entire chapter of graphing functions. This time we're graphing parabolas or quadratic functions. So we need a title for our graph. We're going to label it acorn drop. Okay. The x-axis is time and seconds. And the y-axis is height in feet. Okay. And my height, I'm going to go up by 2s. And my time, I'm going to go by 4ths. So we have 1/4, 1/2, 3/4, and 1. Okay. And now I'm going to graph my results. So I have 0, 20. I have 1/4, 19. So that's going to be between 18 and 20. I have 1/2, 16. I have 3/4, 11. I have 1/4. But I don't know where it hits the ground. So how do I figure that out? Well, if I wanted to know at what time my height is 0, I would just plug. So we're going to bring this down a little bit. And we're going to add 0 here to figure this out. Okay. So I'm going to solve for 0. Now, when I solve for 0, I will have an estimated answer. Okay. So 0 equals -16 t squared plus 20. So let me just. So we're going to subtract 20 on both sides. And we end up with -20 equals -16 t squared. And I'm running out of room here, so I'm going to add a piece of paper. Okay. So we have -20 equals -16 t squared. And we are going to divide both sides by -16. We're just solving an equation here. And we end up with 5/4 equals t squared. But that gives us time squared. And now we're going all the way back to radicals where we have to square root. So we have to square root this time. And we end up with the square root of 5/4 equals t. And you guys are going to love this because now what we can do is we can take our calculator and we can figure this out. So I'm going to take the square root of 5. And then I'm going to divide that by, oops, it's not 4, it's actually 2. The square root of 4 is 2. And divide that by 2. And I get about 1.12. So my time is approximately 1.12 seconds. Okay. So the acorn hits the ground when it is at 0 feet and takes about 1.12 seconds. And so that 1.12 is going to be about right here. And then I can finish my parabola right here. And you don't have an arrow on this one because it stops. It starts and it stops at a specific point. Okay, this was a lot of information. We'll practice this some more. Now our domain is all of our x values. Okay, so the lowest x value is 0. And that is greater than or equal to t, which is x, which is less than or equal to 1.12 because it stops. It starts on, this is your x-axis right here. It starts on the x-axis at 0 and it goes to 1.12. On the y-axis, which is our height, it starts at 0 and goes all the way to 20. So it's greater than or equal to 0, less than or equal to 20 because it doesn't go above 20 feet. It starts at 20 feet. All right, so here, this concludes our lesson for 8-1. There's a lot of information in here. If you have any questions, please email me or come to help class.